In this video, I'm going to discuss about the separately excited DC generator. Now, this is also one of the classification of the DC generator based upon the field excitation. Now, actually, the separately excited DC generator is the generator whose field magnets are energized by the independent external source of the DC current. It says that a separate external DC supply is used to provide exciting current through the field winding. See, in this case, this source is separated from this the armature winding here. So this DC supply is provided to the field to provide the magnetic field. Now the nature of the field winding, it has more number of turns and then less thickness. Now logic here is like you know that your R is equal to rho L by A. Now when you increase the length and reduce the area, so your R will be more. So in order to limit the DC currents in the field, so we have like more number of turns and less thickness. The field current is dependent on the supply voltage and resistance of the field winding. Now you know that now this IF will be directly proportional to the supply voltage of the supply voltage of the supply source, and then the resistance at this field. And now if you look into this the other part, other parts of the generator. Now this generator, the circle one is called the armature. Along with the armature, you will have the shaft. This shaft will be coupled to the other, like the prime mover. Now in case of the hydropower plant, it will be coupled with the turbine. In this way, like again, now along with that armature, we have the brush, which is denoted as A1 and A2. Now from here, your whatever that current or the voltage is induced in that armature conductor is taken out through this to the external circuit, and here we have the terminal voltage, or it is connected to the load, and then we can measure what's the induced EMF at this terminal. Now in order to measure that one, like you should understand that our induced EMF, induced EMF is not equal to the terminal voltage. Now reason is there is a drop, voltage drop in between, and then since this generator is directly connected to the load, your armature current IA is equal to the load current. This is given here, and we know that our induced voltage E is never equal to terminal voltage. Now this is because of the drop, voltage drop across the armature winding, and sometimes we can also consider the brush top. But this brush top, if you compare, like in case of the higher rating of the generators, so this brush top will be very minimum, and then we can neglect that one. But in most of the case, if it is like a small generator, we have to take this brush top into consideration. Now with this, with these two drops, two types of drops, like we have armature drop and brush drop, V brush. So your induced EMF will be equal to, your induced EMF E will be equal to the terminal voltage plus the voltage drop across armature plus the V brush. And then again, from the principle of the DC machine, we have learned that E is also given by the magnetic field times number of poles times the speed of that armature or the rotor, and the number of conductors in that armature winding, divided by 60 times the current path. Now this A will be dependent on the types of armature winding. If it is lap winding, A will be equal to your parallel path P, that number of pole P, and then if it's wave winding, your parallel path A will be equal to always equal to 2. Not always. If it is for the simplex winding, it's 2, and if it is duplex, then A will be equal to, duplex means 2 times 2. If it's triplex, then it should be 3 times 2, and it goes on. So this is how we derive the relationship between terminal voltage Vt and the induced EMF V. So at the end, what that useful voltage is the terminal voltage. This is just the induced inside the armature winding inside the generator, and the one which is taken out is the terminal voltage. Okay, after considering the voltage drop across the armature winding and the brush drop. So that's it about the separately excited DC generator. And then in next video I'm going to discuss about the self-excited DC generator. In the self-excited DC generator, it is again further classified into three types: the series winding generator, shunt wound DC generator, and then the compound wound generator. So again, compound wound generator is further classified into different types. That one I'm going to cover in the next video.